To graph polar equations on your TI84, the first thing you need to do is go to Mode, which is just to the right of the second key, and arrow down, and you'll see that you can choose radian or degree. It really doesn't matter. I'm going to put it in radian mode. Really doesn't matter, except that you have to keep that in mind when you're setting your window, because if you want a full revolution of angles, if you're in radians, then you would set your theta to go up to at least 2 pi. If you're in degrees, then that would have to go to 360. So just be cognizant of whatever your calculator is set in. Then go down here and you'll see function, which is where your calculator is probably set to graph functions y equals, and go over to the third choice, which is POL for polar, and hit enter and select that. Then we will do second and quit and get out of that mode. And notice when you do that, you go to the y equal, and now you have r's instead of y's. So you can graph r1, r2, r3. So your polar equations, you want to solve for r to enter them in the calculator. We need to do one more change, though. You need to go to second and zoom, which will get you into format. And notice the top choice is rectangular coordinates or polar graphing coordinates, and yours is probably set on rectangular, so arrow over and hit enter to set that on polar coordinates. And then do quit again and go to y equals, and you're ready to enter your function. So let's graph sine theta. So r equals, and then we'll press sine and then theta, close the parentheses, and let's check the window. Since we left the calculator in radian mode, when we go to window, we notice our minimum theta is 0 and our maximum theta is 360. Well, if we're in radians, we don't want to go 360 radians. We would like to go 2 pi radians. So let's set that at 2 pi. And then our step, maybe at a tenth. That's how many ordered pairs it's going to graph. It'll go up by tenths if you put 0.1. If you put 1 in there, it'll go 1, 2, 3, 4. That probably is not going to give you enough points, so let's set it at 0.1. And the maximum and the minimum, we know that sine goes from -1 to +1. So let's just leave that the way it is and see what the graph looks like. Okay, it looks oval shaped, but we know the calculator screen is wider than it is tall, so let's do a zoom square. And you'll notice that that makes it look more like a circle. So that's the graph of r equals sine theta. If we go back and graph on that same axis, r equals 2 sine theta, then we notice that the 2 just caused the diameter of the circle to increase. And what if we made that r equals cosine theta? So we'll type cosine theta. And according to our book, this should also be a circle, but notice that it's a circle about the x-axis. And we might need to add a little bit to our window because we're not quite getting all of that. So we need a little more on the negative y-axis. The negative is going down to -0.3, so let's make that maybe -0.2. And now we're getting all of the graph, but again, we've stretched the screen so that we're getting some distortion. So let's go back and do a zoom square so that we can see these really are circles.